So we're going to continue calculating the Riemann sums. So we're going to use the left edge, which is going to represent our lower Riemann sum. So left edge for velocity and time. So I'm going to take the velocity of 3. Our time interval is 2 seconds. So if we take a look at our time interval, it has a width of 2 seconds. So in the first left Riemann sum, which I'm going to do in red, it's going to be 2 times 3 meters per second, or 6 meters here. So we're going to get 6 meters here. For the second Riemann, second rectangle, the width again is 2 seconds, and the height of that is going to be 18. So we're going to get 36 meters for that. So we get 36. And then for the next one, same time interval 2, we have the velocity is 28 meters per second for the left edge. And so we're going to end up with 56 meters. So we get 56 here. And then for the next one, the velocity, left edge velocity is 33 meters per second. So times 2 seconds, we get 66 meters. 66 meters here. And then for the last rectangle, the left edge is going to be 35. So we're going to get 35 meters per second. So the distance traveled for 2 seconds is represented by 70 meters. Okay, and so we don't use that right edge of 51 meters per second. And adding that all up, we get 6 plus 36, 42, plus 56 is going to be 98, plus 66 is going to be 164. 164 plus 70 is 234 meters. That represents our left Riemann sum. And that is, if this is a strictly increasing function, that represents our low estimate. For the right Riemann sum, we've done in green. So for the right edge, I'm going to use the velocity of 18 meters per second. And again, the time interval is 2 seconds. So we're going to end up with 36 meters. For the next interval, we're going to end up with 56. We're going to end up with 66, 70. And then for the right edge, we're going to use that last rectangle, which is 102. So I'm just going to write these in. 36, 56, 66 meters. 70 meters is that area. And 102 meters is the last rectangular area. Maybe I'll just shade that in so you can see that a little bit more clearly. So these are the areas that we're talking about, and these areas represent the displacement in meters. Okay, so we have velocity is our vertical, meters per second times the width, so meters per second times seconds gives us meters. When I add this all up, I get 36, 56, 66. That looks like to be 330 meters is the displacement for our right edge Riemann sum. Okay, so this, and again, if this was a strictly increasing function, this would represent then the upper bound of our estimate. But more importantly, we know that we are able to calculate left edge Riemann sums, right edge Riemann sums, and we know that our areas, those both approximate the area, which also in this particular case, that area is represented by velocity times time. So that area represents a distance of displacement.